So this is our third video on literal equations, and we're going to do some more complicated examples. In the first one, it's a plus 3b squared equals t squared, and we're going to solve for b. So there's the variable that we want, so we have to get it all by itself. So the first thing we need to do is, are there any additions and subtractions we need to take care of? And there are. We don't want to deal with the 3 yet. We want to deal with the a. So I'm going to subtract an a from this side and subtract an a from that side. And I'm going to get 3b squared equals t squared minus a. Okay, so now I'm still trying to solve for b. Do you see that multiplication? The 3b, so we need to get rid of the 3. How do you do it? You divide both sides by 3. Both sides, every single term on both sides. So that's going to leave us with, okay, the 3's will cancel, b squared on the left-hand side equals t squared minus a over 3. And you can't really simplify that. You can't divide the 3 evenly into anything. It doesn't cancel out with anything. You can't combine like terms, so you have to leave it. And then the very last step, this is not equal to b. This is b squared. And if I want b, I then have to take the square root of both sides, which will give me, as my final answer, b equals the square root of t squared minus a over 3. And you can't take the t squared out from underneath the radical because it's connected to all these other things. If t squared was a factor, if that was t squared times a over 3, then you could. But it's a term, it's not a factor, and you can't take its square root and take it out. So this is a kinematics equation that we've been using a lot lately. And I'm going to use it to solve for all the different variables. I'll show you how we would do it. So first thing we're going to do is solve for v0. And you've had to do this before in class. You need to solve for initial velocity. So how do you do it? Okay, so there's what we need, and it's connected to the t, but we can't undo that yet. We've got to wait. We've got to get rid of this 1/2 at squared term. So what do? I'm going to subtract 1/2 at squared from both sides, and that's going to give me delta x minus 1/2 at squared equals v0 t on the right-hand side. Okay? Now it's pretty simple. We need v0 alone, and it's connected to t with multiplication, so we're going to divide this by t, and we're going to divide the other side by t. And that's going to leave us, I didn't leave myself a lot of room, did I? The t's cancel. v0 equals delta x minus 1/2 at squared over t. And no, you cannot cancel that t out because there's not a t in this term. In order to cancel something from the numerator and denominator of a fraction, it has to be a common factor. It has to exist as a factor of both the top and the bottom. And t is a factor of the bottom. It's not a factor of the top. So that's as simple as you can get it. So now we're going to solve for acceleration. Okay, so we want acceleration over here by itself. So now we need to do something to that v0t term, and what are we going to do? Well, it's connected with addition. So we're going to subtract it from both sides. Minus v0t minus v0t. So I get a delta x minus v0t equals 1/2 at squared. And to refocus, what am I trying to do? I'm trying to solve for a. So to solve for a, I need to get rid of the 1/2 and the t squared. In order to get rid of a 1/2, that's a fraction, we multiply by its reciprocal, because our fraction times its reciprocal is 1. So I'm going to multiply this side by 2, or 2 over 1, and this side by 2. The whole thing, not just the delta x. So that's going to give me 2 delta x minus v0t equals, and that 2 and 2 canceled, at squared. And I'm almost done. I'm going to rewrite that here. 2 delta x minus v0t equals at squared. So I have a little bit of room to work. And so my last step, I need a again to be by itself. I'm going to divide both sides by t squared. The t squares cancel, and I'm left with a equals 2 delta x minus v0t over t squared. And again, the t's do not reduce because t is not a factor of every term in the numerator. So we have had the delightful condition, and I say delightful because it makes the work so much easier. If we look at this equation, the original one that we're trying to solve, we have had the case where this term was equal to 0, which leaves us with just x equals 1/2 at squared. And we're going to solve it for t. Notice this is quadratic in t, and if we don't have some initial conditions that are 0, it kind of becomes a problem. But with that term 0, it becomes just delta x equals 1/2 at squared. And if I want to solve for t, I need t by itself. So I need the 1/2 to move to the other side. So we're going to multiply by 2 over 1. And then I get 2 over 1 over here. I get 2 times delta x equals at squared. And now if I want to solve for t, I need to divide by a, right? Divide by a. A's cancel. I'm not done yet because I have t squared equals 2 delta x over a. And so what do? I have to take the square root of both sides, both sides. Notice my radicals come down to show that numerator and denominator are underneath. Please be careful about that. And I end up with t equals the square root of 2 delta x over a. So in the next case, we're up here. Solve for t if delta x is 0, which leaves us this equation. Okay, that looks quadratic to me because you've got a t squared here and a t there. And it didn't go away like the handy-dandy earlier examples. You know, if one or the other of our first or second degree terms is 0, then it becomes a pretty easy equation to solve. Well, this is not difficult either, because what you can do if you only have the first and second degree term, you can divide everything by t. Everything, all 3 terms by t. 0 over t is 0. v0t over t is v0. And 1/2 at squared over t is 1/2 at. Now that's a linear equation. To solve that for t is really simple. Let me do it quickly. I'm going to subtract v0 from both sides. I get negative v0 equals 1/2 at. Okay, now I'm going to do two things at once, which I haven't done in any of these videos. So I'm going to multiply by 2 over 1, and I'm going to divide by a. That will cancel the 2 and cancel the a. So I'm going to multiply by 2 over 1 and 1 over a. So I'll never, negative 2v0. Negative 2v0 equals 2v0 over a equals t. All right. So this last case, which I haven't left myself much room for, but I really am not going to spend much time on it. If none of these things is in this original equation back up here, if none of these things is 0, then you're left with a quadratic equation. Move the delta x over, rearrange it in order of degree, just like you would in algebra. So rewrite this as 1/2 at squared plus v0t minus delta x equals 0. And you can see that this is a quadratic equation. There's my second degree term, there's my first degree term, and there's my constant term. And you're going to solve it using the quadratic formula, and a will be a of the, the quadratic formula has a, b, and c. A is going to be 1/2 a. Okay, that's a little bit ambiguous because of the 2 a's, but b is whatever v0 is, and c is negative delta x. And then you'll just use your quadratic equation to solve if you have to. Okay, those are the more complicated examples.